In this video, we're going to take a look at how to prepare solutions using the dilution method. So we'll be learning how to use the dilution formula. You can try these warm-up practice problems before you go ahead to do dilution. You do need to know how to do concentrations in molarity, so moles per liter, and this would be a great practice question to help you review that concept. And it would also be good to review how to do percent concentrations as well, just so you know the difference between them. So in the previous lesson, you learned how to make a solution from a solid. And essentially, you would weigh that solid, and you would put it into a special flask called a volumetric flask. Then you would add some distilled water until about half the round portion is filled. And then you would swirl until all the solid is dissolved. And then you would add water up until the line over here, the etched line, and really up until the meniscus reaches that line. You would swirl around and shake some more, and essentially you'd be done making your solution. But for that method, you had to figure out how much, what mass of the substance you needed by using your C is equal to N over V formula and finding your moles and then converting to mass. So that's method one of making a standard solution, which again is just a solution with a known concentration. And it was a video that was provided to you in the presentation of the previous lesson, so you could see making a solution in action using that weighing method from the solid. And again, this is just a summary slide of that previous method here. So take the solid, put it into the volumetric flask, add the water. And it really needs to be a volumetric flask. When you're making these solutions, you need to be accurate and you need to be precise with the concentrations. So you want to make sure that you're really using the specialized equipment. You wouldn't be making it in a beaker or a graduated cylinder or some other type of flask. You'd have to use a volumetric flask. And essentially, you would choose a volumetric flask for the amount of solution you want or for the volume of solution you want. So you could choose 150 mils, a 250 mil, a 500 mil. And basically, as long as you fill so the meniscus reaches that line, you will have the correct volume. And so this was the video for preparing solutions from solids. And so we saw that in the previous lesson. Do review it in case you forgot how to do most of it. Go back through the steps, watch the video, and it gives you a good understanding of how to prepare solutions in a lab. Now that is the first method. There's another method that you can use where you don't prepare a solution from a solid, but rather you take a more concentrated solution and then you water it down to make it less concentrated. So for example, if I have a lab, I might buy a very concentrated solution of, let's say, HCl, hydrochloric acid, and I won't use that concentrated solution in a lab for students because it's too dangerous. So what I'll do is I'll take that hydrochloric acid and water it down. I'll add some water to it to make it less concentrated. So it might be a 12 mole per liter solution. And then I turn it into a 1 mole per liter solution by taking a tiny amount of the concentrated stuff and adding water to it. Or the example I sometimes provide is if you think about juice, sometimes the juice you buy in a store is very, very sweet. And it's hard to drink if you don't have a sweet tooth. So what you might do is take a little bit of the juice from the store, put it into a glass, and then add water to it. And so what you've done is you made a less concentrated solution of your more concentrated juice. And that's called dilution, where you water something down. You add more water to make it less concentrated. So the way you essentially do that is you have your flask over here, and this is your concentrated solution. You use a special pipette called a volumetric pipette, and more details to come later. You take a little bit of your concentrated solution using that pipette, and you put it into your new flask. This is your new flask here. You then add solvent, which is water, up until the mark, the etched line, as you normally would for the meniscus. And now you have a more dilute solution. So this was your concentrated one, your sweet juice, for example, your very concentrated hydrochloric acid. You don't want it that concentrated for your lab, or if you're going to drink the sweet juice, you don't want it that sweet. So you'll take a little bit of the concentrated stuff, put it into its flask, water it down, and there's your dilute solution. And so to figure out the new concentration, we have this fancy formula called C1V1 is equal to C2V2. So again, just a reminder, when you're preparing these standard solutions of known concentrations, you need to use specialized tools like volumetric flasks and volumetric pipettes because they allow you to get some nice, accurate, and precise amounts. They give you to 2 decimal places generally. So for pipettes, same thing. If you want 10 mils of the concentrated solution to dilute, you're going to grab a 10 mil volumetric pipette. If you want 20 mils, you'll go to a 20 mil one or a 5 mil one. And so these are specifically and specially calibrated to get that volume of solution that you want. This is just a little refresher slide. Whenever you're measuring those volumes of solutions using the specialized equipment or any equipment, you need to make sure that you're reading from the bottom of the meniscus at eye level. If you don't remember how to read a meniscus, please make sure you review at the link here with some practice activities provided. Same thing over here. So what we're doing in this lesson is essentially preparing a solution by dilution. And dilution basically means you reduce the concentration of a solution by adding more solvent, which is usually your water. So here we have a solution with particles in there and a little bit of water. If we add water to this solution, we still have the same number of particles, but now they're spread out over more water. So this is more dilute overall. So it's like if I were to take that very sweet juice, it has 1, 2, 3, 4, 5, 6 sugar particles. Well, it tastes very sweet right now, but I could make it more dilute by adding some water to it. There's still 6 sugar particles, 1, 2, 3, 4, 5, 6, but now it's spread out between more water. And that's essentially what you did here. That's called a dilution. Your more concentrated solution that you start off with, so let's say the 12 molar or the very sweet juice, that is called your stock solution. So when I order, concentrated acid in the lab to use, I go to that. I grab my stock solution. I grab a little bit of that to dilute it so I can make a lot of the other solutions I use in the lab, the less concentrated one. So the original concentrated solution is called the stock solution. So for example, if I had, let's say, sulfuric acid, very concentrated sulfuric acid, I'd buy a big bottle of it, 18 moles per liter. That's very concentrated. I would never want to give that to students in the lab because it's very dangerous. But I have a big bottle of it. So what I can do is I can take a little bit of the 18 molar and then essentially water it down and get a lot of the dilute stuff, the more dilute stuff that students can actually use. So when I go from 18 molar to 2 molar, I do that by diluting, by mixing with more water, and I've now produced a less concentrated solution, which we can use in the lab more safely. And so we're going to learn how we can predict how much water we need to add to go from, let's say, 18 molar to 2 molar, or to prepare certain solutions from stock solutions. And that's the whole point of what a dilution is and how the dilution formula works. I included a list of steps that you would follow to make a solution by dilution. And there's a great video here made from the same video providers as the previous video for weighing solids. So do make sure you watch this video so you can sketch and explain how to make a solution by dilution. But essentially, you take a volumetric pipette to grab a specific amount of your stock solution, the concentrated stuff, and you're going to put that small amount into a volumetric flask. You're then going to add distilled water until the bottom of the meniscus reaches the etched line. So it has to be the bottom of the meniscus that reaches that, and then you can mix and swirl and shake until everything is well thoroughly mixed and dissolved, and there you have your more dilute solution after. One important safety thing to remember, though, is that if you're diluting an acid, you always want to add acid to water. You never want to, so you want, for example, you want to put the water in the flask first and then put the acid in after. The reason that is, if you do it the other way around, when you mix acid and water, it's a very exothermic process. It releases a lot of heat. And so if you were to add water to your acid, so if you put the acid in here and then put water, it would release so much heat that it might cause some splashback, and that could splash out and cause burns and damage your skin because of the acid as well. So you typically want to put your water in first and then put your acid in, so the water could slowly release the heat and absorb some as well. Sometimes when you're doing a dilution with acids, you might even put your flask in a little ice container or a little ice bath to prevent it from overheating and from splashing. So that's something you might see as well. But if you do mix acid and water together, you're going to feel that exothermic, the heat being released from the environment. So that's a very important safety process to remember. And there's a great video or demo for you to watch here for diluting an acid. So do remember that safety feature. It is very, very important for when you're diluting acids in the lab. Again, this is the preparation of a dilute solution from a stock solution. So the stock stuff's concentrated, and then you take the small amount of stock solution using your volumetric pipette, put it into your new volumetric flask here, then go and add some distilled water to this small amount here up until the etch line, and you have your new dilute solution. So you should know how to sketch and explain the process of dilution. You should know how to provide some safety features when you're diluting an acid, for example, and you can get more details on that by watching the video and reading the instructions over here. Try to make a sketch or drawing where you label the different components using the steps that are provided here and using steps in your video. What we're going to learn, though, is how can we use this formula over here, the dilution formula, C1V1 is equal to C2V2, to predict how much water we need to add to a concentrated solution to make a certain concentration of dilute solution. And so that's called the dilution equation. C1V1 is equal to C2V2, where your concentrations in moles per liter for C1 and C2. The C1 is your original concentration at your concentrated stock solution. The C2 is your new concentration of your dilute solution after you've added the water. The V1 is essentially how much of the stock solution do you need, and the V2 is how much of your solution do you want to end up with. So how much will you have in the end? The volume should be in liters. If they are in milliliters, they both need to be mils. But typically it's nice to have everything in liters because it's in moles per liter here and here for our concentration. And so in our handout, we're going to go and do some practice problems related to the C1V1 is equal to C2V2 concept. Before we do that, let's go and see if we can fill in some blanks here. So we saw there's two main ways to make a solution. There's the method one, which is the weighing method, making the solution from a solid. And so we saw that in the previous lesson. And if you don't remember, just go back and review that lesson. And we had to use the C is equal to N over V to figure out the mass of solid we needed. There's also the dilution method. That's what we're doing in this lesson, where you take some stock solution, some concentrated solution, and basically water it down to make a less concentrated solution. And that's what we are going to see here using the C1V1 is equal to C2V2 formula, the dilution formula. There's a great demo for you to watch over here for how to dilute solutions. Remember that the concentrated solution that we are diluting is called the stock solution. So the stock solution is the concentrated solution that you're diluting. You want to use a volumetric pipette to take the amount you need, and then you're going to put it into a volumetric flask. And then after you put your stock solution in the volumetric flask, you're going to add water up until the meniscus, until the meniscus reaches the etched line over here or the mark. Do remember that if you're diluting an acid, you want to make sure you add acid to water. So you put your water in first, then you add your acid. The trick is add acid to water like you otter. Otherwise, it's very exothermic, it'll splash, and it could cause some severe injuries. So you have to be careful there. Do make sure you know how to read the meniscus. When you're looking at the bubble over here, I see from the bottom of the meniscus, and you have to make sure you're following the right number of decimal places as well. When you're looking at a volumetric flask or a volumetric pipette, you typically get 2 decimal places that you can report to, 2 decimal places. So over here, we have a graduated cylinder. Now, this is not as precise as a volumetric pipette or volumetric flask, so we won't get 2 decimal places, but we can still get some values here. So we go up to 4, we're certain of that, and we go up to at least 4.5. So we're certain of the 4.5. We're just not sure if it's 4.5. So it looks like it's in between 4.5 and 4.6. So we're not 100% sure where it is. We know, again, we passed that 4 mark, and we know we passed the 5 mark. Now, this graduated cylinder has a lot of divisions, so we actually get quite a bit from here. We can actually get another decimal place. You'll notice that we have 0.5 over here, 0.6. So we're not really at 0.6. We're in between the 0.5 and the 0.6 from the bottom of the meniscus here. So we might be 4.58 perhaps. Somebody else might have put 4.57 or maybe 4.59. But the point is that we're able to get 2 decimal places from this over here because we had quite a few divisions. So we're sure of the 4, sure of the 0.5. We're just not sure about kind of where it is in between here. So we can say 4.58. And then here we have some uncertainty. And we know that that's where students may differ. So you might have put 4.59. Somebody else might have put 4.57. Somebody might have put 4.560 to indicate that they weren't sure of that last decimal place there as well. But this is generally how you want to read it from eye level at the bottom of the meniscus. So do practice the tutorials here. if you don't remember how to read from a meniscus and how to read from glassware, because that's super important skill when it comes to diluting. And the remaining part of the video lessons will involve using this equation here, the dilution equation, where you have C1V1 is equal to C2V2 with all the variables explained here in order to solve problems related to dilution. And so we'll see that in the next few videos.